So far in Chapter 3, we have talked about the positive and the negative numbers. Integers is what we call them mathematically. Understanding what an integer is going to be vital because we're going to be figuring out how to use integers mathematically. How can we add positives and negatives and subtract them and multiply them and divide them? The exact same thing that we did with decimals at the beginning and then fractions, that's Chapter 2. Now we're going to be dealing with our integers in Chapter 3. But understanding what they are and how they are related and where they go on number lines will help us figure out how to interact with them in the four functions of mathematics. Now this big fancy word of rational numbers is what Chapter 3, Lesson 3 is all about. And please don't make this a difficult concept. It's not designed to be a difficult concept. They just want you to understand that we do have specific names for numbers. We have whole numbers. If we talk about integers, then it's taking the whole numbers and talking about not just the positives, but also the negatives. And then if I talk about rational numbers, well, you already know several rational numbers. You know what a decimal looks like. You know what a fraction looks like. You know what a mixed number looks like. Rational numbers want you to understand that it's anything that can be looked at number-wise that we can count, going forward or backwards. So all decimals that are positive as well as negative. All fractions that are positive as well as negative. All mixed numbers that are positive and negative. So the rational numbers include all of the numbers that are inside that large oval. That's what a rational number is. The book gives you a definition, right? The book says, well, a rational number is any number that can be written as A over B. A over B, it's a fraction, and we know that fractions are what mathematically? It's division, right? So they're saying there are any numbers that we can divide. I can divide a big number by a small number. I can divide a small number by a big number and get decimals. I can leave them as fractions. I know that I can use a positive and a negative because it says an A and B can be integers. We will learn how to divide with with negatives and positives. The only thing is that it can't be 0. I can't have B as a 0 because I can't divide by 0. If I have 400 things, can I put it into 0 groups? No, I can't do that. So my B can't be a 0. That's all it's saying is everything that would fit onto this chart. If it's a positive, a negative, a whole number, a decimal, a fraction, any of those mixtures and combinations, that's what rational numbers are. Knowing how to look at rational numbers and where they would go in relationship to number lines, that's the key to this lesson. This lesson is not designed to be difficult. It's designed to show us how to think about how I would plot some of these mixed numbers or these decimal numbers that are negatives. We know how to plot positives. You've been doing it for a couple of years now. Negatives sometimes get a little tricky. So the blue, once again in our book, is what we should be thinking. If I'm not sure how to figure this out, how would I think about it to figure it out? And then they give you these little blue ideas to get you thinking. If I don't know where to locate -3, it's -0.3, excuse me, -0.5 and 1.4 on a number line, then here's where I would begin. -0.3. Well, we could probably plot positive 0.3 because we've done that before. And so it says, well, think about what the opposite of -0.3 is. And we talked about opposites, right? If it's a negative, I just make it a positive, and if it's a positive, I just make it a negative. So I take my -0.3 and I make it a positive 0.3. Easy enough. If I think about where that would go then on a number line, what two numbers would that be between? Well, it's more than 0, but it's less than 1 because it's 3/10. So I know that if I would plot it, it has to be between those two numbers. In the same way then, think about if that's the two numbers it has to be between for a positive 3, its opposite, its original number that we were talking about, would have to be in between the opposite numbers, right? So 0 doesn't have an opposite, it's just 0. But the opposite of positive 1 is -1. So if positive 3/10 is between 0 and 1, then -3/10 has to be between 0 and -1. Well, what about -0.5 or -5/10? Same idea. if I know that it has to be the opposite, would be between 0 and positive 1, it also is going to be between 0 and negative 1. Well, what about 1.4, 1 4/10? Well, that one's pretty easy because we've done those for a couple years now in school. I know it's more than 1 because it's 1 and a decimal added with it, and it's going to be less than 2, so I know that it's going to be in between a positive 1 and a positive 2. So then when I go to plot them, notice these are not horizontal number lines, they're vertical number lines. So the positives at the top, you have your 0 at the bottom, negatives go down. I have to look at what those tick marks are telling me. If I just count 1 and then I go up 3 or down 3 of those tick marks, I'm going to be in the wrong spot, right? Because when I look at it, I have 5 tick marks in between each number. From 0 to negative 1 or 0 to positive 1, there's 5 tick marks. That means that each of those is worth 2/10, 0.2. Because from 0, I would have 0.2, 0.4, 0.6, 0.8. 1.0 would be my 10. If I'm looking to plot negative 0.3, then I know I have to go down 1, because that's negative 0.2, and then halfway in between. That's where my negative 3/10 is going to be. If I do the same thing for negative 5/10, well, now I have to go down 2 of them, because I'm going down to negative 2/10, negative 4/10, and then just halfway in between. So negative 2, negative 4, my negative 5/10 has to be right there. 1 and 4/10 then, I have to go all the way up to the 1, and then I have to only count 2 tick marks, right? Because there are 2/10 per 1, 0.2, 0.4, so my 1 and 4/10 has to be there. All right, Mr. B, so where's the hard part? Well, we're going to find out there really isn't a hard part to this lesson. It should be pretty easy as long as we're thinking and we're engaged and following along. Honestly, the people that struggle with this lesson are the ones that don't pay attention to that old saying that says the people who are going to be first in life will end up being last in the end, and the people who are last in life end up being first in the end. It's the same idea sometimes in math. I've got a couple of you who are like, vroom, I got to be the flash and be the first one that gets this done so I don't have anything to worry about on homework. That's not what it's about. It's about taking your time and just thinking about it and doing it correctly. I'd rather see you be the last person to turn in your assignment and get an A on it than the first person to turn it in and have a whole bunch of silly mistakes on it. All right, so in this example, we see a chart here. It says points of interest, and we have the names. We have city park, we have fountain, we have library, we have mall. Well, I don't see any image that goes with it. What's it say then? It says City Hall is located at point 0 on a map of Maple Avenue. Other points of interest on Maple Avenue are located on the map based on their distances in miles to the east of City Hall. Positive numbers or the west of City Hall, which are negative numbers. So if City Hall's in the middle, then we know going to the east, to the right, we have positive, to the left, we have negative. Graph each location on a number line. And then we have these different numbers. And they ask you what 2 numbers are they going to go in between. So when I start looking at them, I have negative 3/8. So we did decimals, now we got to do fractions. And I know it's not one whole, right? It's not a mixed number. So I know it's going to be between 0 and negative 1. When I go to negative 1.5, then when I look at it, I know that it has a negative 1, so I have to at least go that far. But it's a mixed number, it's greater than negative 1. However, it doesn't quite get to negative 2 because my whole number is negative 1. So it has to be plotted between negative 1 and negative 2. Once again, the whole idea of this lesson is just being able to figure out where they should be plotted correctly, because we're going to need to be able to do that for the rest of the school year. 1 1/4 then should be easy. I know I have to go at least to the 1, so it has to be between the 1 and the next whole number, and my next whole number is a positive 2. And then 3/4, positive, I know it's more than 0, right? But not quite 1, because it doesn't have the whole number. So it has to be plotted between the 0 and the 1. When I look at the number chart that they give me then, they say, well, this is City Hall in the middle. So now we're going to figure out where each of these are going to be plotted on their number line. Should be pretty easy because when I start looking at it and I count my tick marks, if I look at those 0 to 1, I have 1, 2, 3, 4, 5, 6, 7, 8. Great, because my denominator is an 8. I can do that pretty easily. If I have a -3, then I just have to go back. How many? I go back 3. So I'm going to go 1, 2, 3. It's got to sit right there. 3 tick marks behind. All right. And when I look at what I said it was going to be between 0 and -1, 0 and -1, I got it, right? Perfect. And then I go down to, oh, come on, -1.5. My denominator is supposed to be an 8. But I notice from here to here is my whole number, right? And what's in between each of my whole numbers? The halfway mark. All right, well, that's actually easy. So I know we said it has to be between the -1 and the -2. So I go to the -1 and then I look for the halfway tick mark. It's going to be right there because it's the next biggest one. Or if I don't see that there's a difference between the halfway mark and the big ones, then I have 1, 2, 3, 4, and 4 out of 8, that's a half. All right, so that really wasn't as difficult as I thought it was going to be. Even though it has a different denominator, I could figure that out pretty easily. So the next two have to be easy too, right? No, because now it has 1/4 and 3/4. So what do I have to do? Have to get a common denominator, right? Well, I'm not comparing any numbers, I'm not, but I know that my denominator needs to be a denominator of 8, so I know where it goes. So I have to do my math where I change my denominators. If I have 1 and 1/4, well then my whole number of 1 is going to stay the same. And my fractions, I'm just going to multiply by 2. Why do I multiply by 2? Because my denominator has to be what? It has to be 8. So if I need a denominator of 8, my whole number of 1 stays. I take my 4 times 2 is 8. If I multiply the bottom by 2, have to multiply the top by 2. 1 times 2 is 2. Now I know I'm just going to go over 2 of the 8 tick marks that are given. This is a positive number, so I know it has to be between the 1 and the 2, and that's what we set up there. So I'm going to go to my 1 and then go 2 over from there, and that's going to be 2 out of the 8 tick marks that get me over to the whole number of 2. And now I have 3/4. Still can't do it right, so I have to think. I need a denominator of 8, so all I have to do is multiply my 3/4 by 2 and 2. So I multiply the same number by at the top and bottom. 4 times 2 is 8, 3 times 2 is 6. So now we said it's more than 0, but it's not quite as equal to 1. So I just have to go over 6 of the 8 tick marks because that's what the numerator tells me. So I know that 6/8 is going to be plotted there. All right, so what about these questions? How did you identify the two integers that -1.5 is in between? Well, basically what it's saying is, what did you think about? Well, I thought about, I know that I need to start with a number that's before -1, right? Now when I say before, if I think about my number line, before is over here. It's my -2. Then what do I have to think about? Well, then I have to go to the following number, which is the -2. So it has to be between the -1 and it has to be between the -2. How did I figure out where it was going to go? Because it's greater than -1, it's less than -2, has to be between the two numbers. Not difficult, right? Figuring out where these go. Well, it's not designed to be difficult. It's actually designed to be very easy. Once again, the only problem that I have is I have some people, they aren't going to follow along because they're going to say, I know how to do this is easy, and then they rush through and then they really make silly mistakes. So please just simply make sure that you're listening and paying attention, following along, building that rote memory with your pencils, doing it as I say it, because this is only going to last a couple more minutes and then you're going to have the rest of the time to do your assignment. Graph the number on the horizontal line, horizontal once again going straight across. I have a -2.25. The numbers between that these integers are going to go, well, it has to be further to the left than the -2. but not quite as far as the -3, right? Because it goes further than -2. So I know I have to be in between the -2 and the -3. Which one is it closer to? Well, -0.25, that's 1/4 out of 4 quarters for a dollar, right? That's what 25 hundredths would tell me. Because when I look at it, I have 1, 2, 3, 4. I have 4, and if it's divided into 4, that's 1/4 each. So if I know that it's only 1/4, it has to be closer to the -2. I have one of them that's going to go to. Now, the other way to look at it is this is said 25 hundredths. And if I have 25 hundredths, I can reduce that by 25s. And when I reduce that by 25s, then mathematically I can prove that it is 1 out of 4 quarters that gives me $1. So I only have to go over 1 tick mark. So it's more than -2 to the left, and it's only 1 of the tick marks that they give us out of the 4. What about -1 5/8? Well, when I look at 1 5/8, it might help because these only have 4 tick marks. If you need to, go ahead and add those extra tick marks. It's not required, and I'm not going to grade you if you don't have them, but if you see it better by showing that I have 8 tick marks now by putting 1 in between each one, I'm fine with that. Whatever you need to do to be successful in math is fine, as long as it's actual mathematics that makes sense. So if I go to my -1, and then I keep going to the left, right, because it's greater than that -1, then I go 1, 2, 3, 4, 5, with those extra tick marks in there. It's going to go right in the middle for my 1 and 5 out of the 8. And then 3 and 1/2, or excuse me, the number 3, just 1/2 tells me that I have to go halfway between what 2 numbers? 0 and 1, right? Because it doesn't have a whole number with it, so it has to be more, but it has to be more than 0. So right between my 0 and my 1, I have a bigger tick mark. If I don't see that there's a bigger tick mark marked in the half, then all I have to look at is that there are 4 in between from 0 to 1 and from every number, so I have to go 2 of them. All right, so we're going to wrap up and only do 3 more. State whether the numbers are on the same or the opposite sides of 0. Wait, that's all I have to do is tell if it's on the same or the opposite? Yeah, that's all you have to do. It just wants to make sure that you understand what side they're on a number line, because that's going to be important on future lessons. Well, this is a negative and a positive. They're on opposite sides, right? And those are 2 negatives. They're on the same side. Those are easy. And I agree. Number 19 then says, the roots of 6 corn plants grew to -5.4. How does a root plant grow? I mean, they grow, right? Well, they're just saying is if I have a ruler in the ground next to the root, it's going to grow, which is going to show positive growth. But what they're saying is if the ground is at 0, then going down, that's becoming my negative numbers. Because if I think about something growing negatively, it's actually have to be shrinking, and that gets a little confusing. Don't let it confuse you. It's just how deep in the ground it's going to go. So it has to show as a negative. So I have -3 and 54 hundredths, a -2 and 4/5, a -3 and 86 hundredths, a -4 and 1/8, and then a -4 and 4/25, and then finally a -3 and 2/5. Now, wow, when we did fractions and decimals, I had to have common denominators, or I had to make them all decimals. Is that what I'm doing here? Nope, it's a lot easier than that. How many corn plants had roots between the 3 and the 4 feet deep? And feet deep, once again, indicates negative numbers. So if I think about a number line, what they're saying is between the -3 and the -4. So anything that's going to fall in between these 2 numbers on a number line. Well, okay, so it has to be further to the left than the -3, but further to the right than the -4. Does that work there? It does, right? Because it has a -3 in front, but it's still a decimal, and it's not going to go past the 4, so I know that one works. How about the -2 and 4/5? No, that's going to be over here. Doesn't quite get to the -3. So that doesn't work. How about -3 and 86 hundredths? Yep, that one works. -4 and 1/8. No, it goes too far. That one doesn't. -4 2500ths. That one goes too far. -3 2/5. Yeah, that one works. So how many corn plants have roots between 3 and 4 feet deep? 3 corn plants. Just answer the simple question. So once again, this is not designed to be difficult. I'm leaving several of these just in case you do have questions as you're going through it. It's not designed to be difficult. It's actually designed to hopefully you get 100% on your assignment. Anytime, especially when we're getting close to report cards, which are next week, anytime we can get an A on an assignment, it's going to help boost our grade a little bit. And there's a couple of you that can really use some help to get that grade up. If you have any questions, then please come and ask and we'll work through some of those extras. If not, just remember, it's just only talking about any number that we can count with. Positives, negatives, it doesn't matter if it's integers or not, whole numbers, decimals, fractions. So don't make the idea rational number, big, fancy, tricky math term. It's not. It just means everything we count with. This is your assignment. Get to it. If you have questions, come and see me.